Hello everyone, my name is Fargiza A Mulki. I'm from Astronomy Research Group, Faculty of Mathematics and Natural Sciences, Institut Teknologi Bandung, Indonesia. On behalf of my team would like to share our work entitled Non-Canonical Domain Walls as a Unified Model of Dark Energy and Dark Matter. This is a small part of my work which is still under preparation for journal submission. Ladies and gentlemen, as we know that after the discovery of cosmic acceleration, many major missions or observations confirm the requirement of dark energy to account for the late time acceleration. For example, observation of supernovae type 1a, cosmic microwave background, large-scale structure of the universe, and baryon acoustic oscillation. This altogether shows that the budget of the universe is dominated by unknown energy called dark energy. The simplest model to describe dark energy is a cosmological constant. However, we know that no single dark energy model satisfactorily solves those problems. The cosmological constant itself, as a standard model of dark energy, suffers from serious problems. Let's say fine-tuning and coincidence problem. Therefore, several alternative models like coming from slow rolling canonical scalar field, for example quintessence with various potential, freezing, towing, coupled, assisted, etc., and KSN from non-canonical scalar field have been put forward, either based on formal physics theories or through phenomenological approach. These alternative models initially focus on solving the cosmological constant problems, such as through introducing scaling condition, attractor solution, anthropic principle, then take low limit on effective field theory. However, these approaches are less than optimal. Hence, many authors carry out extension to the coupling case between dark energy and dark matter. Currently, new challenges emerge in cosmology, namely cosmological parameters tension that are H0 and sigma E tensions. The conflict between result of local measurement of those cosmological parameters and those of CMB Planck observation indicate possibilities of unknown physics, which mostly attributed to our lack of understanding about dark energy. These convert models tend to be more phenomenological since the cosmological tension become more significant. And finally, most models were intended to relieve cosmological tension. And then the fundamental problems of dark energy itself, concerning its energy scale, acquire lesser attention. You know that phenomenological models are less convenient to explain the classical and fundamental problems of dark energy. Then what we need is a more formal and well-motivated model that stand upon established physics theories. So let's solve around grand unified theories. We know that a grand unified theory is a unification theory of fundamental interactions excluding gravity. This theory explains physical phenomena at high energy levels, one of which is related to very early universe. One of grand unified theory's prediction is topological defects that is emanating from the phase transitions during cosmic inflation. If we look back in time, we will find several authors propose the idea of expressing dark energy as domain walls by employing canonical Lagrangian. Unfortunately, the cosmological observation in the next following years dropped the model due to constraints obtained from many observations at that time. Why? Because the equation of state parameter of domain wall of canonical domain wall cannot reach around -1 today. However, ladies and gentlemen, the dynamic properties of domain walls following the non-canonical formalism until now have not been investigated. So, uh, let's investigate the non-canonical formalism for domain wall or for soliton. Suppose we have a simple non-canonical Lagrangian as follows. It is very simple Lagrangian, where n here is an integer and bigger than 1, and this Lagrangian is invariant under the Lorentz transformation for a single value of n. And we can find the equation of motion, or EOM, and also we can find the energy momentum tensor of this field. We have to deal that by definition a soliton is a static solution of the scalar wave equation, which the kinetic time term of the equation of motion here vanishes. Well, in principle, a domain wall is an extension of a king. It means that if we place king solution in a higher dimension, in a higher spatial dimension, we will have a planar structure called a planar domain wall, or simply domain wall. And then here in this work, we assume there exists a dense network of walls within the cosmic horizon, and this network has not lost much energy during history of the universe. Then we can estimate the evolution of its energy density. Well, we see here that the pressure and density of the domain walls depend on the average value of V. V here is potential and V dot is kinetic component. And most domain wall models have a constant V potential in time. Then we can guess that the time dependence of density and the pressure lie in the V dot component. Okay. And we also see here that the pressure grows more negative as the universe expands, and we see that the imaginary term in both equations are consequences of the quadratic term in the Lagrangian. Well, in the next slide we will see that an appropriate transformation will cancel out the imaginary terms in these two equations. We assume that the time dependence of density and the pressure are caused by Lorentz boost. Then the spatial coordinate that experiences Lorentz boost is perpendicular to the wall plane. Okay, and up to this point we get an idea of how one might overcome the imaginary parts in the energy density and pressure shown in the previous slide. If we take notice to this equation, we discover that a domain wall resembles a phantom field. However, we know that phantom stability is still an open topic in particle physics as well as cosmology. One possible solution to avoid the instability problems is by assuming a freezing condition for the domain wall. It means it doesn't move according to the observer in comoving coordinates. Okay. How about the dark matter and dark energy properties of the domain wall? Well, ladies and gentlemen, cosmological observations show that around 96% of the energy in the universe is the dark sector, namely dark energy and dark matter itself. Well, these two things are still not well understood. The nature of the two entities are different. For example, if we see on the large scale, the dark matter muffles the expansion of the universe, while on the other hand, dark energy boosts and accelerates. On a small scale, the flattening of the galaxy rotation curves shows that dark matter interacts with baryonic matter through gravitational fields. Meanwhile, small-scale observations indicate that dark energy does not affect the dynamics of the bodies in the solar system. Well, although the empirical properties of the two are very different, several authors attempt to unify dark matter and dark energy and perceive them as the same entity. Why? The philosophical reason for this unification is related to our lack of understanding of the true nature of the two entities. Our presumption regarding the distinction between the two may be unreliable. In addition, a more practical reason is perhaps we want to theoretically depict them through only one theory or model. And in this work, we discovered that the non-canonical domain walls in certain circumstances can behave like dark energy, and in others behave like cosmological dark matter. These figures show the evolution of the equation of state parameter of the domain wall along the expansion history of the universe for several velocities. Note that domain wall with any velocity will converge to equation of state equals 0 in early time. In other words, all non-canonical domain walls are initially created as dark matter. Okay, then as the universe expands, the pressure of the domain walls become more negative and slowly takes over the corresponding density, and the equation of state parameter becomes smaller and smaller. Well, we see that the higher the velocity of the domain walls, the slower the decrease of equation of state parameter with the expansion of the universe. So there are several walls that fall into phantom zone at that epoch. Okay. Well, domain walls that enter phantom zone are those that have velocities smaller than a characteristic velocities today, which the value is around 0.6. And in the previous slide, we have shown also that domain walls have negative kinetic energy unless they are frozen or the velocity is 0. However, ladies and gentlemen, this figure confirms that domain walls with velocity equal to 0 today are in the phantom zone. Okay. Because domain walls have constant velocity, those that are frozen today also frozen in the past. So they never possess kinetic negative energy along their trajectory. So here, phantom zone and phantom state refer to two distinct things. Phantom zone is a region in which the domain walls have equation of state less than -1, and a phantom state is a state in which the kinetic energy of the domain walls is negative or ghost. Let us analyze the stability condition of the non-canonical domain wall. Well, suppose a small perturbation around the field, and we take the perturbation of the Hamiltonian. You can see the textbook here. And this Hamiltonian perturbation will be either positive or 0 if the following conditions are satisfied. And in addition, we also have to involve the classical stability analysis, criteria, and causality principle. In this work, we find that these two first conditions are satisfied by freezing domain wall. This is expected because from previous slides regarding the stability of domain wall, we have shown that the freezing domain wall is stable, perhaps stable. This third stability condition related to the potential is met by domain walls whose the second derivative of the potential with respect to the scalar field is either 0 or positive. Okay, and then also we have found that the freezing domain walls satisfy the other condition. They also obey the special relativity conditions and hence do not violate the causality principle. How about the cosmic dynamics of the universe filled with domain wall? Okay, Suppose a flat universe contains matter, radiations, and freezing domain walls as a dark energy. Okay, and the background dynamic of the universe is described well by Friedman equation, acceleration equation, continuity equation for perfect fluid, and the EOS parameter of each constituent obeys a simple perfect fluid equation of state. Obviously, we talk about the background dynamic, not perturbation dynamic. Okay. Well, this figure shows the cosmic evolution for the freezing domain wall model with the input parameters taken from Planck collaboration and Brightens. This figure shows the completion of the non-canonical freezing domain wall model in causing late-time cosmic acceleration. We see at early times, when the radiation drives the dynamics of the universe, energy fraction of the domain wall is extremely small, with equation of state parameter nearly zero. As the universe enters into the transition era of matter radiation, the fraction of radiation decreases with increasing energy fraction of matter. As matter increases, domain wall also increase, while equation of state of domain wall at that time unchanged. Over a long time, matter and domain walls share portion of energy, so that matter density parameter during this era is less than unity. Okay. However, because domain walls share a part of matter energy density, since they behave like matter, so the effective matter density parameter is a total of them, that is 1. Okay, and at late times, domain walls start to deviate from their matter properties, and the equation of state parameter gradually goes toward negative, and slowly their dark energy properties emerge. According to the freezing domain wall, we see that the transition from matter-dominated era to domain wall era occurs at factor scale around 0.75. Okay. Oh, I'm sorry. Around 0.8. Okay. Well, ladies and gentlemen, this is the summary of this talk. Thank you.